This video is for section 11.3. Our objectives in this section are to find the common ratio of a geometric sequence, write terms of a geometric sequence, use the formula for the general term of a geometric sequence, use the formula for the sum of the first n terms of a geometric sequence, and find the value of an annuity. So we're going to start by talking about what a geometric sequence is. And then the problems that we're going to do are going to be similar to the problems that we did for arithmetic sequences, but we're going to have a whole new set of formulas here. In a geometric sequence, the same number, which is called the common ratio for geometric sequences. If you remember, we had the common difference for arithmetic sequences. So the common ratio is multiplied by each term to get the next term. So for arithmetic sequences, we add the same number to each term to get the next term. For geometric sequence, we multiply each term by the same number to get the next term. So we're going to start with example 1. It says to write the first 6 terms of the geometric sequence with first term 6 and common ratio 1/3. So first term is 6, and then I multiply each term by 1/3 to get the next term. So 6 times 1/3. When multiplying fractions, if you don't remember, you need to multiply the top times the top and the bottom times the bottom, or multiply across, and you need to have your answers simplified when you enter them into MyMathLab. So 6/3, I need to simplify that to 2. So I get 2 for the second term. Then I need to multiply that by 1/3 to get the third term. 2 times 1/3 is 2/3. And then for A4, the fourth term, it'll be 2/3 times 1/3, which is 2/9. The fifth term would be 2/9 times 1/3, which is 2/27. The sixth term is going to be 2/27 times 1/3, which is 2/81. So just like when we've done this before, each term is going to have its own separate answer box. Once you get one correct, then it'll open up the answer box for you to enter the next term. So you should look at checkpoint problem number 1, do these in your notes, check your answer, and then move on with the rest of the video. Next, we're going to have a formula for the general term of a geometric sequence. Just like we had with arithmetic sequences, this formula allows me to find any term by plugging in. So if I want to find the nth term, or the general term is the formula that I can plug in to find specific terms of a geometric sequence. With first term A1 and common ratio R is A sub n equals A sub 1 times R to the n minus 1 power. So when I'm doing problems with this, I need to remember order of operations, exponents comes before multiplying, so I need to do the n minus 1 power first on R before I multiply by A sub 1. So we'll look at example 2 here. It says to find the 8th term of the geometric sequence whose first term is -4 and whose common ratio is -2. So the formula that I'm plugging into is A sub n equals a sub 1 times r to the n minus 1. My a sub 1 here is negative 4. I want to find the 8th term, so n is 8. And my common ratio is r, which is negative 2. So I'm looking for a sub 8. Plug in negative 4 for a sub 1. Plug in negative 2 for r. And then this is going to be 8 minus 1. So you can type this all into your calculator. You need to use the parentheses that I have written in here in order to avoid mistakes, or you can do it piece by piece. If I do negative 2 to the 7th power, because 8 minus 1 is 7, then negative 2 to the 7th power is negative 128. And negative 4 times negative 128 is positive 512. So 512 is my answer. So you should look at checkpoint problem number 2. Do this in your note, check your answer with the notes, and then move on with the rest of the video. So next we're going to look at a formula for the sum of the first n terms of a geometric sequence. We had this formula for arithmetic sequences as well. So our formula for the sum, which we use S for the sum, S sub n, of the first n terms of a geometric sequence is S sub n equals a1, the first term, times 1 minus r to the n power over 1 minus r, where a1 is the first term, and r is the common ratio. So that's the formula that we're going to be using here for sums of geometric sequences. So we're going to look at example 4. It says to find the sum of the first 18 terms of the geometric sequence. So what I need to identify here, I'll copy the formula down, is a1, r, and n. So a1 is pretty easy. That's going to be 2. N, what I want to find is the sum of the first 18 terms, so that means that n is 18. And r, if I look at any two consecutive terms, I see that I'm multiplying by negative 4 to get the next term. So if I say, okay, 2 times what equals negative 8, that's negative 4. Negative 8 times what equals positive 32, that's also negative 4. So I multiply any term by negative 4 to get the next term. So r is negative 4. So I'm going to plug these in. A1 is 2, 1 minus. Now you have to be careful here because, again, exponents needs to come before I do this subtraction. So I can't change this minus negative 4 to plus because I need to do negative 4 to the 18th power first and then subtract that from 1. On the bottom, I can make that change because the 4 isn't raised to any power. So I can change this just to plus, 1 plus 4. But I can't do that on the top again because of this exponent. So for this one, when you type it into your calculator, the answer here is a little bit strange because it's a pretty big number. So if you type it in, you'll probably see something like this. negative 2.7487790,694 times 10 to the 10th. Or your calculator, depending on the calculator you have, it might say E10 at the end. That means that the answer is written in scientific notation. And you won't really see this on the homework because the numbers that we're going to be working with are a lot smaller. But your calculator is writing this answer in scientific notation. So you'll see if you look in the book, they have the answer written out as a number. It'll say that the answer is 27,487,790,694. But on your calculator, whoops, it's negative. On your calculator, you will probably see, again, this, and you see that the number is the same, but what's happening is they're moving the decimal point 10 places, and that's why it says e to the 10 or times 10 to the 10th. So just be aware of that. Again, you won't really have to worry about this on any of the homework problems because they're all going to be smaller numbers than this. But for some reason, the book decided to put a really big answer here that kind of throws off the calculations. So you should look at checkpoint problem number 4, do this in your notes, check your answer, and then move on with the rest of the video. The last example we're going to look at here is example 5. It says to find the following sum, and it gives you a summation notation. So again, we're identifying 3 variables here. So let me copy the formula again. Obviously, you don't need to memorize any of these. You just need to probably have them kind of written down in some concise place to use on the final exam. It would be good. So this is the formula. So I need to identify first term, r, and n. So looking at the summation, I'm going from 1 through 10. So that tells me that I'm adding 10 numbers. So n is 10. For the first term, I'm going to plug in 1 for the variable. So 6 times 2 to the first, which is 6 times 2, which is 12. And then to calculate r, what I'm going to do is find the second term and then compare them. So for the second term, I'm going to plug in 2 for the variable. That's going to give me 6 times 4, which is 24. So what do I multiply by each term to get the next? I multiply by 2. So that tells me that r is 2. So from here, I'm just going to plug in a1 is 12, r is 2, n is 10. So this is s. I wrote s sub n, but it's s sub 10, the 10th, the sum of the first 10 numbers. And then I have 1 minus r is 2. So again, you can do this piece by piece or type it all in at once into your calculator. If I do to the 10th, that's going to be 1024. 1 minus 2 is negative 1. 1 minus 1024 would be negative 1023. And if I multiply this out, I should get 12,276. I should get a whole number because I'm adding up a bunch of whole numbers here, so it would make sense that my sum would be a whole number. So next you should look at checkpoint problem number 5. Do this in your notes, check your answer, and then move on to the homework.